So the first thing I want to talk about is how do we get useful information from science on climate change? The precautionary principle says that we need to not take big risks. If there's a risk, don't take it. You don't need to know for sure that the risk is going to happen. You just need to know that it's a possibility. And the thing with the climate science is that the information that comes out tends to be quite conservative because of the processes involved. So what a scientist might say down the pub or to a journalist is one thing, compared to what they'll say in a single peer-reviewed paper where they try to say exactly what they know within that paper. And of course they may have collected the data incorrectly or analysed it wrongly. And so you get more rigour by reviewing a specific area of data, getting lots of different data sets. That has more rigour in it. And then the Intergovernmental Panel on Climate Change spends a lot of time looking for consensus across different fields and what the whole area is telling us. And of course, as that becomes more rigorous, it takes more time. Some people feel that IPCC has been deliberately hamstrung through this consensus process. So how then do you deal with the science? There have been some people that have been accused of cherry-picking the worst-case scenarios, and they've been called alarmists. And actually, there seems to be more agreement these days with what the, in quotes, alarmists were saying. So I don't know whether they are right or wrong, but that's not what we intend to do today. We're using the voices of mainstream scientists. On the other hand, the panel 3 of the IPCC contains economists and policymakers. Many scientists believe it shouldn't even exist. And it is, in the words of Kevin Anderson from the Tyndall Centre, highly politicised. So really what we want to do is find the useful sweet spot to give you the good information. And I think this graph really helps to show the difficulty with the IPCC process. It's the melting of the Arctic sea ice, showing the September minimum, and the blue is the range of melting seen from IPCC models. I'm sure they probably updated this recently, but this was where it was at not long ago. And in red you see the actual observations, the actual data, and of course science is based on observation. That's what it's about. The data is everything. And the data and the models are way off fundamentally. And this has led actually to, especially it seems to be more this year, but in recent times, for some scientists breaking rank, I would say, it's traditionally academia is quite conservative, as I've said, but now you have Professor Hans Schellnhuber, who is the head of the Potsdam Institute for Climate Impact Research, senior advisor to the Pope, advisor to Angela Merkel, the German Chancellor, and the European Union. A credible voice, right? And what he's saying is that climate change is now reaching the end game. The issue is the very survival of our civilization. The What Lies Beneath Understatement of Existential Climate Risk paper out this year talks about how climate policy making has become embedded in a culture of failure and scientific reticence. It argues for urgent risk reframing of climate research and IPCC reports, and it contains voices from some of the world's leading scientists. So let's dig a little bit into the science to look at temperature and tipping points, feedback loops and impacts. Looking more closely at the data from the Arctic, which is the black wiggly line, you have statistical processes where you try and fit a line to that data and predict what's going to happen. So this is the September minimum, and basically what the data's telling us, if you know the yellow line's not a good fit, it's a straight line. The other lines that fit better say that the ice will be gone around 2023, the next 5 years, give or take. I mean, none of this we know until it happens, but that's what we're being told by the data, and obviously it's being updated all the time. The melting creates one example of a worrying feedback loop of climate change. It's called the albedo effect. So when the Arctic sea ice melts, it turns from this white stuff that reflects sunlight back out away from the planet, and instead you have a dark absorbent material that absorbs more heat. It absorbs more heat, it creates temperature rise, more Arctic sea ice melts. It's a feedback. It's called a positive feedback loop. There's nothing good about it because it's positive. So that leads the Yale Climate Connections folks to say climate change is not a matter of cause and effect, it's more like a vicious circle. And so this has moved this year into the idea of abrupt climate change, that there may not be just feedback loops, but sort of domino cascades of feedback loops. It got called the Hothouse Earth paper, the PNAS paper that came out in 2018, and it looked at 10 different feedback loops: permafrost thaw, loss of methane hydrates from the ocean floor, weakening land and ocean carbon sinks, bacterial respiration in the oceans, Amazon dieback, boreal forest dieback, reduction of northern hemisphere snow cover and in other places. And looking at all these different feedback loops suggests that the Earth can tip from just 2 degrees C, which is what the Paris Climate Agreement moves around. At 2 degrees C, could tip into this hothouse Earth state and stay there. So, as many scientists have said, 2 degrees C is not a good move. It needs to be 1.5, and that was never a great move either. So this leads one of the authors, Johan Rockström from the Stockholm Resilience Centre, to say 50 years ago, and I'm sure even 5 years ago, this would have been dismissed as alarmist, but now scientists have become really worried. And when the temperature rises, and you can see the rise in the temperature on the graph from the Met Office, we're at there's a debate, but around 1 degree C above pre-industrial levels, and it's rising at about 0.17 a decade, but there's lots of reasons why rises wouldn't be linear. So a Nature paper came out recently. It's from the University of Washington, and there was also UN warming estimates that said the idea of holding to 2 degrees C within the lifetime of people born today is highly unlikely. In fact, we've got a 1% chance of hitting the 1.5 degree target. We've got a 5% chance of hitting less than 2 degrees. The likely range is between 2 and almost 5. The median is 3.2. You have horrendous consequences at that temperature rise. And these temperature rises are in the lifetime of children today. It's catastrophic. This stuff should be on the news every night, right?